Welcome to part 1 of the Netconf tutorial. This is a 30-minute session. We will firstly, in a couple of minutes, define what Netconf is. Then we will step back and look at the requirements put forward by operators and service providers, why there was a need for a new standard for doing configuration management. We will deep dive a little bit into transactions, since this was a fundamental requirement. We will wrap up the session by doing some live network management using a Netconf enabled device and various management tools to actually do management in a standardized way. First of all, here is the 2-minute elevator explanation of Netconf and Yang. What is it and why is it useful? If we simplify things from a technical standpoint, we have management applications and network management systems, OSS systems, network automation systems, and such. They need to be able to remotely read the configuration data in the devices, be able to remotely write and change that configuration across several devices. So that boils down to we need a remote protocol. We need something that can read and write data over TCP/IP. So that's the actual protocol. How do I read? How do I write? How do I perform actions? That's the protocol. But a protocol is nothing without a formal definition of its payload. So if Netconf lets me read an interface or change an interface, what are the attributes of an interface? So that corresponds to the Yang models. So every device is described by Yang data models, and so in this case I have 3 devices. If they're different, they obviously have different Yang data models, and so the management application has the Yang data models, thereby know when they read the interface, they understand the data that is retrieved. Also, when they need to change an interface based on the Yang models, they actually know which attributes can be changed on an interface. So the Netconf, that's the protocol. It's a remote protocol, and the Yang models tells what the data can be read and written. So I'm carefully saying it's a data model. And what is a data model? A data model it's very concrete. It defines exactly which data can be read and can be written, describes it explicitly and precisely, the structure of the data, the syntax and the semantics of the data. And this is, of course, the data that is externally visible for a management system, for a client. So it's not a model of the software inside the box or anything like that. It's, if you see the device as a black box, what can be read, what can be written. And it's a complete model. Everything that can be read and written should be there, and it's consistent. So good modeling characteristics. And then the protocol obviously needs to have remote primitives to view and manipulate that data. And protocols also defines the encoding. It makes sense to compare Netconf with something well known as SNMP. So protocol. We all know about the SNMP protocol with gets and sets and get next. And there's the level where Netconf protocol lives, but with a different set of operations, with different characteristics based on the requirements we talked about previously. Data models, well, there was and is MIB modules. In Yang, you talk about Yang modules. So a set of Yang modules makes up the data model for the device. Sometimes there's a bit of confusion between information models and data models. I'm generalizing a little bit, but information models are more targeting humans. They're targeting the problem of domain experts being able to discuss and share knowledge between each other. Information models are not necessarily targeting automation software, parsers and tools. So that's the thing. And typically you start with an information model that sometimes is graphical, sometimes not. Based on that, you make it precise, you make it exact into a data model. So information models are a useful starting point for a data model, but information models are not precise enough to be used by software. Protocol, there's sometimes a bit of confusion between people saying, why do we need this Netconf? Can't we just have SOAP or REST or anything? What you tend to forget then is that Netconf is a domain-specific protocol that knows about network management, that understands configuration management, and that lives on a general RPC mechanism, in this case SSH and an XML RPC, whereas SOAP and REST are general purpose RPCs. You could, in theory, build a good management protocol on top of SOAP or REST, but there is no guarantee, and more important, there are no standards. So remember, Netconf is a full IETF standard. You can interrupt test a device claiming Netconf, and it will enable plug and play directly with management systems. Taking general RPC mechanisms can never be interrupt tested and will always assume a lot of integration work. So that was the introduction. Netconf, protocol, Yang, data model. Where does it come from? What's the background? What actually made this thing happen? There is a very good reading. I strongly recommend all of you to read RFC 3535. It's an RFC that describes actually a meeting. There was a workshop in 2002 where network operators were brought into the room to discuss with IETF around what's the focus for IETF regarding network management in the future. And the conclusion was quite easy to see. SNMP is in place and it's useful for monitoring. But when it comes to configuring, it's not being used. There were some attempts to have SNMP work for configuration, but that failed. So if you look at how is configuration performed today, it's CLI scripting, and of course vendor-specific CLI scripting, and that was the big take from the operators. We need something that is standardized for doing configuration management, and they put together a number of requirements in this document. So not designing any protocols or anything, just collecting what are the most important requirements for operators when it comes to a standardized management interface. Ease of use, number one. Ease of use is a very sloppy requirement, hard to test, but what it means in this context is if you're an operator and you buy an equipment, you should be able, without having 15 integrators there for 3 months, being able to receive the alarms, and even more important, being able to configure the box. That the standard must imply an easy-to-use, pluggable interface from the management system to the devices. That must be easy and be able to automate, not requiring humans for doing everything, not requiring large software projects for supporting a new device. Another very important characteristic, which is nothing new, every good CLI has a clear distinction between how to retrieve the config versus seeing statistics. Show running config shows you the configurable variables, how they are configured currently. That's one thing in contrast to operational state and statistics. So for CLI engineers, this is obvious, but on the other hand, if you look at in the SNMP world, there is no clear distinction. You can't ask an SNMP box for give me your config. You can walk the MIB and you get all the variables. Firstly, you don't know what is config, what is operational data. And the later thing is, if you fetch that, there's no way to easily copy and paste that into another box. So clear separation between config data and operational data. That should be clearly denoted for every single piece of item in the data model. Is it config or operational data? And you should easily be able to compare. So you should be able to get the config from one device, get the config from another device, and compare that to see how they are different. Requirement number 4 and 5. It's very interesting. Operators said that we need to be able to configure the network as a whole, not just peeking and poking variables in single devices, but to be able to provision, say, a VPN across the devices and think about that as a atomic transaction. So network-wide transactions, configuring network services rather than just bits and pieces in individual devices. And this puts transactions in the focal point, transactions across devices. Ordering is a tricky thing of many less useful configuration interfaces. If I need to set A and B in a device, it's very tricky to know if do I need to set A, B, or do the device require me to do B and A? This shouldn't actually be something that the management system needs to know anything about. The management system should be able to say, set these variables and you device, you figure out the ordering. It's not up to me to fix that. So that's the ordering thing. Secondly, connecting back to previous slides about being able to clearly distinguish between config and operational data, you should be able to, in a very simple way, pull the config from one device, push it to another. And I think this is a very useful litmus test. I've come across various homebrewed management interfaces for device vendors currently that experiment with RPC mechanisms of various kinds, and many of them, surprisingly enough, forget the basics. Is there a show running config? Can I, in one operation, get the complete configuration? Can I have that in a file and paste that into another system? So this is a very easy test. Can I get the config, store it, push it to another device? Because this is the way operators typically work. Maybe get the config, edit a couple of variables, and then push it to another device. And it's very important that you should be able to get the complete. So getting the config from one box to another should make the other box being a complete copy of the other, bringing it into the exact same state. No hidden things that are not visible. All the configuration should be able to get and be able to push down to another one. Remember that litmus test. Go back to your lab. Can you do that with all your devices? Consistency is important, of course, when it comes to configuration. You should be able to prepare a configuration. You should be able to validate that at the network level. Is this a valid configuration? Will it work? Does it violate any constraints? Next, text-based configuration. It's also, that goes back to the previous requirement on the previous slide. You should be able to get the config and inspect the textual representation. Again, compare with SNMP where it's binary. There is no chance you can get the SNMP variables and bring them up in an editor and expect and change and paste into another one. So text-based configuration was a primary requirement because that opens up a whole universe of tools where you can diff text files, you can have small automation script that parses text and changes text, so that's a fundamental requirement in a good config management protocol. Clear text representation of the config data. Also, continuously compare with SNMP. One thing that is good with SNMP is that there is a fairly large amount of standardized MIBs. Then, of course, the question is, do the different vendors support the standardized MIBs? Do they implement the MIBs accordingly? But that's a secondary question. At least there is a library of standardized MIBs, and the same goes here. I mean, if we have different vendors and all routers have interfaces, could there actually be a standardized interfaces data model, very much like the IF-MIB in the SNMP world? If we're moving on to configuration management, we certainly need standardized data models for the fundamental features of the devices, so that can be shared among vendors. In some protocols, whatever you do take immediate effect. If you do an SNMP set, it happens immediately. What operator said here, it's very important to distinguish between sending the configurations down to the devices is one thing, activating them is another thing, because that helps you build up an orchestration sort of deployment. You should be able to send a config, and then finally commit it. So separation of actual the happening and the distribution of the configuration. Also, devices should be able to hold multiple configurations. A fairly common pattern is that you have a running data store, you have a candidate data store, say, so you can manipulate the candidate data store until you feel you're done, and then you commit the candidate to the running. That's one example of holding multiple configurations. So if we step back, what's behind all these requirements, and if we would fulfill these requirements in the standard, how would things change in the industry when it comes to configuration management? If we look at current situation, from devices, there are no well-defined protocols and data models for doing configuration management. There's a lack of atomic transactions, meaning that when you change things, some might go through, some might not go through. It's very hard to do rollbacks. There's always trick around ordering. You never know which pieces need to be set before the other ones. So going from one state to another, you need to, in the management system, deduce the ordering, and even harder to deduce the reverse ordering to achieve a rollback. So that creates a lot of cost and complexity for the service provider, for the operators, in order to integrate devices into their management systems. This gives rooms for the huge integration tax we have for every new device type, for every new service type. Slows down the whole industry because we need to kickstart a software project for every new device and every new service. Having Netconf and Yang in place and well implemented as well, not well implemented, not just a tick box in the RFP, would change the gameplay a little bit. Netconf and Yang would put more requirements on the device vendors, would increase the cost. Need to be honest here. It requires transactions, it requires the devices to fix the ordering, not the management system. So we're pushing a bit of complexity from the NMS system down to the devices. But on the other hand, the value of the devices will be much more increased. So if devices would support transactions, standardized data models, and standardized protocols, we could reduce the cost and complexity, and drastically reduce the time it would take to introduce new services and devices in the NMS. So this is where this standardized solution is pushing, and will help operators greatly. So that was a requirement, and as a result of that, I have started the working group firstly around Netconf, and after that the Yang data modeling language that goes in hand with Netconf. So what you will see pretty soon is that the requirements we've been looking at here are fulfilled by Netconf and Yang together. Let's look at where it comes from. Standards doesn't come from the blue, neither from printers. There are always human and brilliant engineers behind successful standards. So starting with Netconf. Netconf is actually rooted in technology from Juniper. So with the background requirements we've been looking at, Juniper brought their technology to IETF, and so that's primarily Phil Schaefer and Rob Ans from Juniper. So what happened there is that their technology was standardized and called Netconf. Looking at Yang, what are the roots for Yang then? Several roots. Along with the technology from Juniper, they also had a XML schema for writing the data models. That was one input. We have Jürgen that's been working with SNMP and been working on an SMING, meaning next generation language for writing MIBs. And also Martin Björklund from TailF had a vendor-specific language. So those three different inputs was the roots that emerged into Yang. And there was also a lot of work from Ericsson and David Pertain that actually made the standard happen. So let's continue. At this point, we will move on to a quick demo. Rather than going in more theory, let's see Netconf and Yang in action. So it's time to put theory into practice. I will do a tiny demo with a tiny Yang data model. So let's start by looking at the module definition. Don't be scared about syntax at this point, we will explain the details later. You put individual modules into a module, obviously, and you give it a name. And don't take this as a design pattern. You shouldn't make a huge Yang for the complete device, so rather make small modules. And the device puts together several modules to describe the complete functionality. Anyhow, we can skip the administrative stuff in the beginning and get to the actual data. Variables in the data are called leaves. So here we have a simple leaf called name of type string, a state of type enumeration, good or bad. You can group leaves into containers. So containers in this case is sort of a logical grouping where to find these two leaves. And we have another container called interfaces, which has a list of individual interfaces. Every interface has a name and has a type. And when you define list, you need to specify the key, and it can be one or several leaves that together makes up the key. In this case, the interface name is the key. In the bottom here, we have a very useful type called the leaf ref. So in this toy example, we would like to denote which of the interfaces is the management interface, called the management IF. A very simple and stupid model would have made this into a string, which meant that you could write foobar as the management interface, although it didn't exist. However, it's a leaf ref and a specific path into the data model. So the slashes here denotes a path. So you see interfaces, interface, name. So this leaf ref can only reference existing interfaces. If you would try to set this to something else, it would be rejected. If you would try to delete an interface that is referred to by leaf ref, that would also be rejected. So this is a data model that describes my simple box. I have a device up and running that supports this data model. I have the device supporting Netconf and a CLI. And I pre-configured the device a little bit. Let's look at the configuration. So remember, I had one container called properties, I had another one called interfaces. So it's configured with the name box100 and state is good. And a couple of interfaces, and one of them being appointed as the management interface. So this was using the local CLI, but Netconf is about being able to have remote applications automatically configure devices. So I will show a bit of Netconf now. I will start by using a Netconf browser. There are various Netconf browsers on the market, which gives you a handy tool to learn and navigate and see what's going on here. We start by connecting. So an SSH authentication here. So where I start right now, I haven't loaded any Yangs or anything. This is a totally empty client. I just entered the IP address and logged into the Netconf server in my box. When the Netconf client and the Netconf server start talking to each other, the first thing they do is hello, and the hello exchanges capabilities. And capabilities tells sort of the supported features so that the client and servers can adapt. This is a very interesting capability. The Netconf server tells the Netconf client which data models do you have, which Yang modules. So here you see that the server supports Acme box. We will utilize that later on. Other things are part of capabilities, standard Netconf capabilities. So this device has a writable candidate database, so I do the edits towards a candidate, then I commit the candidate to the running. But I can't do much without the data model. In the SNMP world, you had to call the vendor or try to go to some anonymous FTP sites and try to understand which MIB you should find and load to speak to the device. But since I got the capability up here, telling the name of the module, there's also an optional feature to ask the Netconf server about, can I please get the actual data model over the wire? That's a separate feature. It's part of a Yang data model called Netconf monitoring. So I will do that now. I will ask the device, which data models do you have? It tells me I have Acme box. I can tick that and say download. So the management system on the fly downloads the actual data model. I got it. And this means that I can update my management system with that specific data model. Totally online. So in the browser I see the same thing here now. Properties, name state, interfaces. Let's start a little bit simple. And by the way, here you see the output XML. Over the wire I got this. I got the data model in Yang syntax. Okay, let's do a little bit of Netconf. Get config. Netconf clearly separates configuration data from statistics and operational states. The Yang data model we had, it didn't say anything, but the default when you write Yang data models is that if you don't say anything, it's considered configuration data, meaning things that the management system can write, things that needs to be part of a backup and can be restored. So this data model, everything was actual config. So let's get the config. Read the running data store. The capabilities told the client that there's a running data store and the candidate data store, but we're interested in the configuration of the running data store. So here we see the output, box name, box date. Remember exactly what we got in the CLI. The tool can also render an output tree. Let's check the interfaces. Let's check the output XML. See the various interfaces, its name, its type, etc. No magic. So remember what happened here. When I started the client, it was totally empty, no clue what about the capabilities, the actual data models. But due to Netconf, first of all, Hello Exchange, where I discovered the capabilities such as running and candidate, also supported data models. By the device supporting Netconf monitoring, I could on the wire download the correct data model. And now I know the individual fields that I can configure and read, so I could immediately start inspecting the individual. I could interpret it. So this is a reading config. Let's go on and do a little bit of editing here. Maybe change the name. Change the name to box 0. So let's look at this part. The whole operation is an edit config operation, and we are targeting the candidate database. Again, repeating myself, when we did the hello, the server told me that it has a candidate and a running. So I will write to the candidate database. Later on, I will commit the candidate to the running. And what goes in the config tags here then must adhere to the specific data model for this specific device. So here you see the namespace. I'm referring to a specific namespace here that must exist in the data model. So look up here. The Acme box had this namespace That's what's appearing here. And it has the container properties and a leaf called name, and I'm setting that to box 0. Validate it, fine. And let's go, send as RPC, so I'm sending the edit config RPC to the box. I got the response back, okay. So at this point I've started a transaction towards the candidate database in the box. I can continue, edit other parts, and then do a final commit, which will commit the candidate to the rounding. In this case I will commit immediately. So commit. This means copy candidate to rounding. If everything worked fine here, we can go back to the device and inspect that we actually changed the box name to box 0. So previously it was box 100. Let's see what we have now. Box 0. Surprisingly enough, it worked, right? So that was using a tool, but remember that one of the requiremements for Netconf was to use text-based representation. I mean, this sort of looked as an SNMP MIB browser, but MIB browsers needs to decode and encode binary data. But everything in Netconf is XML plain text. So I can do the same thing with a text-based Netconf client. I have one here called Netconf console. First, let's do the hello. You see the same thing here. And let's read the interfaces. So here I'm saying, should actually not say get to be correct on a tutorial. We should actually do a get config. Get gives you both config and operational data. This would be the same in this specific example because the complete data model is config data. If I would have stated something in that data model as config false, the get config would not retrieve that, but the get would actually have retrieved that as well. So get me all the configuration that is available under a specific path. So -x here stands for below this XPath expression. So give me all the interfaces. Here we reckon the interfaces again. Let's do the same with properties. There are the properties. So I hope you got a little bit hang of Netconf and Yang in practice here. We will now take several steps backwards and start from the beginning, explaining the Netconf protocol and the Yang data modeling language in more carefully.